Hello, Namaskar, Vanakkam. Welcome back to CBSE with Sudhir, where we are doing the second chapter of Curiosity textbook. This is for students of class 8. I hope you have already seen the first chapter as well as the first part of this particular chapter, which is the invisible living world beyond our naked eye. Okay, so I hope you have seen the first part. And now we are starting with the second part. The same chapter has also been explained in Hindi for those of you who may be more comfortable understanding it in Hindi. The remaining chapters, health also has already been done in Hindi, but the remaining chapters I will largely explain in simple English. So before I start, just want to let you know to please share the video, subscribe to the channel and press the bell icon. Also, please know that Win with Sudhir is a YouTube channel for students of class 9 and 10. So when you get into class 9 next year, that's the channel you need to follow for class 9 and 10, where I'm going to be teaching you English and social science in simple English, focusing very sharply on these two subjects because my target will be 100 on 100 in these two subjects. Okay, so that's what we need to get into. So let's get started with the textbook. What are the levels of organization in the body of a living organism? We stopped here in the first part of this particular video. Let me just shut off the sound on my phone so that there is no disturbance while I am teaching. So a body of a living organism is actually organized in a very complex way. And you always wonder, wow, what an intricate, complex way of organizing the body of any living organism. What are the different structures that we find, right? The cell is the basic unit of life. Let me just put this here. I'll just look to annotate it. Let me pick up my pen. Okay, let me quickly pick up my pen so that I can mark it for you and then I will show it to you separately in the notes also. Okay, now you see that the cell is the basic unit of life. This is something which you need to know. Just like when you are building a wall, what is the basic unit? It is the brick, right? So when you are building a wall, you will arrange the bricks like this, right? You will arrange the bricks. That's how you build a wall. Similarly, the cell is the basic unit of life. A group of similar cells forms a type of tissue. So when there are many cells together, that's what forms the tissue. This is the tissue out here in the diagram on the left-hand side of your book. Different tissues are organized to form an organ, right? An organ is what you have inside your body. It could be the liver, it could be the kidney, it could be the spleen, it could be the pancreas. So when different tissues come together, they form an organ. So what have we learned so far? 3 steps: cell, tissue, organ. CTO. Okay. Then the organs work together to form an organ system, which could be your respiratory system, which would obviously include the trachea, the lungs, etc. Then you have the digestive system, the circulatory system consisting of your heart, your arteries, your veins, the different blood vessels. That is entirely the circulatory system. Then you have the excretory system, you have the reproductive system, you have the endocrine system, so consisting of endocrine glands. So you have essentially different kinds of organs. When they come together, they form the organ system. So now let's remember it with the word S. Okay, alphabet S for system. So CTOS. Okay. Then performs a major function of the body. All the organ systems together make up a complete organism. So what we have is CTOSO. CTO. If you remember it, you will never get the order wrong, because the mistake many students make is to get the order wrong. They don't know which comes first and which comes after that. Okay. So these levels of organization help us understand how simple building blocks like cells come together to form a complex living being. Okay, let me just show it to you in this presentation. Now, if you see here, okay, you have the cell. Okay, this is what the cell looks like. Then it forms the tissue. Then the different organs. This is the heart. Okay, which is like dil ki dhadkan, right? Then you have the different organ systems, and then this is the entire organism from head to toe. All this is inside our human body. So levels of organization, the life of a living organism begins with a single cell, which can be an egg. It can divide repeatedly to form a complete living being of many cells. They are called multicellular organisms. This is what I am going to go into next after this. So the life of a complete, this is what I said, it starts with egg. The egg of any organism has an amazing ability to divide and thereby multiply, right? Such living beings are called multicellular. Wherever you have more than one cell, it is called multicellular. If there is only one cell, it will be called a unicellular, unicellular. Okay, so animals, including humans and plants, are all examples of multicellular. We are a multicellular organism, right? But there would be certain kind of organisms which will be unicellular. We will study that in this particular chapter. For example, when we are talking about, in the later part of this book, there is given, for example, you have amoeba, you have algae. Algae, of course, is both unicellular and multicellular. Bacteria, which is unicellular, right? All these things are either unicellular or multicellular. But remember, all animals, plants, and human beings are all multicellular organisms. Then, this is an interesting piece of information that is there. That is, we are talking about the ostrich. Ostrich is called the shaturmurg in Hindi. The yolk, which is the yellow part of an egg, jab anda todte hain, you see the yolk, the yellow part, that is known as the yolk, Y-O-L-K, of an ostrich egg. The egg of an ostrich is a single cell, the largest known cell in the living world. And that is something very amazing. It's almost like a record. The largest known cell in the living world, measuring about 130 millimeter to 170 millimeter in diameter. The egg contains extra non-cellular material, which is a shell for protection, and a white liquid inside. Like this, you see the white liquid that nourishes the cell during its continued development, right? So that is what is the role of the white part, and what does the yellow part do. So this is as far as the ostrich egg can come as a 1 mark MCQ, or a true or false, or a fill in the blanks. Okay. Now, what are microorganisms? What I just now referred to, we need to understand that in detail. What exactly is a microorganism? Now, some living organisms are made up of just one or few cells. They are so small that they cannot be seen with the naked eye. You need either the microscope or maybe the magnifying glass. They are called microorganisms. Micro is something very tiny, right? Microorganism. Okay. Some microorganisms like bacteria and amoeba are made of just one cell, which is unicellular. What I just now told you. If you have many cells, it is multicellular. If it is one cell, it is unicellular. Okay. Others like some fungi and algae. Okay, some fungi, not all fungi. For example, algae are both unicellular and multicellular depending on the variety of the algae. Okay, have many cells, multicellular. They are found all around us in water, soil, air, and even inside our body. But what do their cells look like? Are they like the plant and animal cells we just learnt about? So we just need to find out with the help of different activities as to what do they look like. This is going to be very fascinating. Let's move forward. So let us observe. So what you need to do is to, and these are experiments and activities which you can and should do at home. Okay, it's a very fascinating kind of activity. So what you do is to go to maybe some kind of a water body which may be near your house, maybe a well, maybe a pond, maybe a lake, wherever, right? And pick up some stagnant water from it. Okay, don't drink it. Okay, just pick up some stagnant water from it. Stagnant means ठहरा हुआ पानी, which is not flowing. Take a container and collect pond or stagnant water in it with the help of your teacher or elders. Okay, I want you to do this activity and I want you to put it in the comment section. What are the findings you found? It will be very fascinating. Okay, Use a dropper and place a drop of pond or stagnant water on a microscope. This you can do subsequently in your laboratory, or foldscope slide. Put a cover slip, that is, you put it on a slide, you put a cover slip on top of that drop of water, okay, and observe it under the microscope. With the naked eye, you may think, ye pani to saaf lag raha hai, this water is looking very clean, right? Ana, when you put it inside under the microscope, Appo, what you will find, okay, what you will find is going to be a very fascinating, invisible world with the naked eye. But under the microscope, you will be able to observe the tiny organisms which are actually found inside that pond or stagnant water. Okay, then the other activity that you can do is to take a beaker. Now, these could be fungi, fungus, it could be algae, it could be some bacteria also. Depending on the power of the microscope, you will be able to observe them, because if they are very tiny and if your microscope is not very powerful, you may not be able to see it. But if you have a very powerful microscope and the organism is slightly big, you will be able to see it clearly. Next activity, you take a beaker and collect some moist soil, that is some soil, okay, which is a little moist, which means there has been, you may have watered it a day before, so the mud is still a little wet. There is some kind of moisture or humidity in it. From the nearby field or a garden, do not touch the soil with your bare hands. Use gloves. Gloves is always important to use it, because you don't want to catch any kind of infection. Now pour some water into the beaker and stir it with a glass rod. Okay, you put some water and you in the soil, you mix it with water. Okay, and you kind of, with some kind of a spoon or any kind of a rod, you kind of stir it, right? Now the liquid, you will find it looks dirty. It is not completely white. It's not clear. It is muddy water. Obviously, you have mixed soil with water. It is called the soil suspension. Keep it aside for some time and let the mixture settle. Let the mixture kind of settle at the bottom. The water will be on top. The mixture, the heavier soil, will actually settle at the bottom. Now use a dropper and take a drop of water from the top layer. Place the drop on a microscope slide. Now this water, you need to take a drop of it and put it on the slide. Cover it with a slip, okay, and see it under the microscope. Okay. Cover it gently with a cover slip and observe it under the microscope. You may observe small moving organisms similar to those you saw when you took it from the stagnant water, right, in the previous activity. This indicates that even soil suspension, that is soil mixed with water, contains a variety of tiny creatures. In fact, in class 7, we have studied that in social science also, right, that you kind of have many kind of earthworms, insects, or any other kind of organisms which are in the soil who actually do a lot of good work, right? So a variety of tiny creatures that cannot be seen with the unaided eye, that is without the microscope. The tiny creatures that cannot be seen with the naked eye are called microorganisms. Micro, as I just now told you, means very, very tiny or very small. Organisms means living beings or microbes. Okay, microorganisms or microbes both mean the same thing. Okay, now another activity 2.6. A group of students studying in grade 8 performed activities 2.4 and 2.5, and I do hope you and your teachers also encourage you. I mean, you are encouraged by your teachers to do these experiments also. Okay, now they recorded the data obtained after observing pond water in table 2.1 and the data obtained after observing soil suspension in table 2.2. So you put it in different tables. They identified the organisms, that is the different microorganisms that they have got, microbes they have got. They are either protozoa, they are either algae, they are fungus, or even bacteria, right? So these are the different kind of organisms that they have found in both the activities. The first one is amoeba or protozoa, which is a single cell, which means it's unicellular, moving and irregular shape. It does not have a regular shape. It just keeps kind of moving in different kinds of shapes, and one amoeba shape will be very different from another amoeba shape. Then another kind of protozoa, which is the paramecium. Okay, it is also a single cell. It moves from one place to another. Movement takes place with the help of specialized structures. You know, these kind of hair that you see, it kind of moves with the help of these kind of specialized structures. Then the third one is algae, which is also unicellular, right? Though algae can also be multicellular. It can be both. Okay, it predominantly unicellular, but as I said, multicellular also. It looks green because it has a pigment chlorophyll. Movement takes place with the help of specialized structures as well. Then the fourth one is the bread, now which are found in the soil suspension. Now first three are found in the first activity 2.4. In 2.5, you find different or microorganisms or microbes which are in the soil suspension. The first one is the bread mold. If you keep a piece of bread, and that is something again which you can do it at home, keep a piece of bread that you buy from the market. Okay, don't keep it inside the fridge. You keep it outside, preferably in a place which has moisture, which is a little humid. Okay, you will find that after a few days, there will be some kind of a mold which will be formed, a fungus which will be formed on the bread slice. Okay, you cannot eat it, you should not eat it. Okay, these are branched filaments without chlorophyll having sac-like structures. You see these kind of structures on the top. Then there is this mold, which is also a form of fungus, branched filament without chlorophyll having brush-like structure. This is another kind of fungus. Now, this one, the mold fungus, is multicellular in nature. Then algae, which can be both unicellular and multicellular, they are spherical, presence of chlorophyll, which is a green pigment. But I told you, you need to be familiar with all these kind of different terms, because these can come, as I said, in MCQs. And going forward in class 9 and 10, you will be studying about all this in much greater detail. Then finally, bacteria, which is unicellular, spherical, spiral, rod shape, one long hair-like structure and many small hair-like projections around the cell. This is bacteria. So we say no bacterial infection, viral infection. Then you see algae in the pond water or in the soil, fungus in the soil. For example, during the monsoon, or if there is some seepage coming from the floor above you, there can be some kind of seepage which can be formed on the wall, right? There would be some kind of wetness on the wall. That is also a kind of fungus which is being formed on the wall, right? Whenever there is water leakage through the wall, right? So that's what manifests itself as seepage and some kind of fungus, which is again harmful for those who live in that house, which is why you say that if there is seepage in the wall, you need to call a plumber and get the thing corrected as soon as possible. Okay. Now, did you also observe any of these microorganisms, something different, right? So these are all somewhere, and you need the microscope in order to be able to see it. Then you have the virus. Apart from the fungus, the algae and bacteria and amoeba and paramecium protozoa, you have something called the virus. Virus is not the dean in Three Idiots. Okay, virus is what causes the maximum amount of problem in the human population. They are microscopic, that is, you need microscope to observe them. They're acellular. Viruses multiply. Now, the fascinating thing about virus is that they do not, in fact, I've written it out here, which is very fascinating information, that they cannot eat, they cannot grow, they cannot reproduce by itself. How do they do it? They are completely inactive or inert outside a living body. They need to be inside a living body. And once they are inside a living body, they play the role of a hijacker. They hijack the cells inside the body and to create various copies of the virus, which is why when you get a viral infection, you realize that the virus has multiplied inside your body, which is why you develop fever, you develop other kind of symptoms, right? That is what really happens in the case of a viral infection. So viruses multiply when they enter a living cell. Very important. They may infect plants, I mean, not just humans, animals, plants, or bacterial cells, and they may cause a disease. So the maximum, though I must also point out that bacterial infection is sometimes even more dangerous than a viral infection, right? So, but virus is something which you get, we say, no, viral fever, why? Some viral fever, change of season, you catch a virus, and that goes inside your living body and uses your living body in order to multiply several times. Okay, so you need to take an antibiotic to kill the virus. Okay, only when you kill the virus, it will stop multiplying inside your body. Now, before we go, let me just show it to you in this presentation, just to do a quick recap. So microorganisms or microbes are tiny living organisms that are so small, okay, that are so small that we cannot see them with the naked eye. Okay, they can only be seen with a microscope. Examples are bacteria, virus, fungus, protozoa, and some algae, found almost everywhere, cause diseases, but also help in making of curd or baking. Now I will, once I explain to you, then I will come back to this. Okay, now we have seen, we have understood about microbes so far. Okay, now if you see this kind of a fruit, okay, you don't keep it in the refrigerator, you keep it outside. This, what you see, is a microorganism like fungus which has developed around this santra, around this orange. Okay, now it is unfit to be eaten. You cannot eat it. If you eat it, there is high chance that you may fall sick. Okay, now what this happens because microorganisms can be found everywhere. Okay, now why do microorganisms not infect the pickles and the murabbas? Now that's an interesting question. This is because you add many spices with salt or sugar into it, which act as preservative, which means it preserves what has been made, and therefore none of these microbes can infect it. High concentration of salt or sugar do not allow these microorganisms to grow on them. Okay, so that is an interesting kind of a question, which also you can get as a 1 mark or a 2 mark reasoning questions. Okay, I will make those test papers which will really help you understand and be able to answer many such interesting reasoning questions. Okay, so all this we've already studied, so I will not go through that. So let's do an activity. Take an empty container, fill it with garden soil, add some fruit and vegetable peels to the container, then put a layer of soil on it and leave it aside. After 2-3 weeks, observe the changes. Do you observe any change? Now, what is the change? You may find that peels of fruits and vegetables have turned into a dark colored material. This is manure, because that leaf, etc., that you have put. In fact, if you see, 1 minute, let me just, this class 7 social science book number 2, if you remember, there was this thing called kulagar, okay, which was a way of agriculture in Goa, right? So what they do is to put a lot of leaves, etc., on top of the top soil, so that you kind of maintain the moisture and the humidity of the soil. The sunlight does not fall directly on the top soil. But here what happens, and over a period of time, it will develop into humus, the organic matter will work on it, and it becomes manure, which is rich in nutrients and helps increase the fertility of the soil. Okay, so that's what happens. Instead of throwing out the kitchen waste, your orange peels, your banana peels, your the peel of something else, etc., you can actually make use of it in order to increase the fertility of the soil by making it as manure. Now, some of these microorganisms like fungus and bacteria act on the plant waste and slowly break it down into simpler, nutrient-rich manure. Now, this manure is very important because it is organic manure. You're not buying any chemical fertilizers in order to make the soil rich. You are using natural things which will be completely not harmful to the environment. It will be good for the environment. You're not mixing chemicals into the soil. Okay, so that's what gardeners do. In fact, even in my neighborhood park, what we will do is that whatever trees leaves are shed, what he will do is to kind of collect them all together and put them around the plants. Over a period of time, the earthworm, the insects, etc., they will keep working on it, and that gets converted into manure for the plant. So this is like original organic kind of manure. Ancient Indian texts, particularly the Vedas, have references of the words krimi, which means different tiny entities, including drishya and adrishya. Drishya is something which is visible, You know the movie called Drishyam, right? What is visible, Adrishyam is what is not visible, right? Various Vedic texts mention their beneficial and harmful effects. Atharveda also refers to krimi. Okay, just a tiny kind of an information note. Okay, this is all interesting. Let me just, okay, this is all just about the activities. Let's move forward. Now, microbes as a source of biogas. Okay, before I go, let me just show it to you this one. So what happens is that while we talk about bacteria or a fungus being harmful, there are some good use also. For example, bacteria also helps in the making of curd. How do you make curd? आप दूध को उबालते हैं, you boil the milk, you keep it outside for a certain temperature so that it kind of cools down, but it should not become absolutely cold, right? You keep it outside for some time. When it is at the right room kind of temperature, just about lukewarm, you will mix some curd, 1 spoon of curd, and leave it like that over the next 3 to 4 to 5 hours, depending on the outside temperature. If it is normal summer, it will get converted into curd. What happens? Because a bacteria is actually working on it in order to convert the milk into curd, right? If you keep the same milk inside a refrigerator, it will not work because that bacteria needs a certain amount of warm temperature in order to be able to work on the milk to convert it into curd. So there are some positive advantages also, positive benefits also of the bacteria. Similarly, you have another fungus called yeast. Okay, yeast is something which is mixed when you are doing baking and you are baking a cake. That's where yeast also comes in handy. So that's a form of fungus. So if you are asked about the advantages of a fungus or a bacteria, this is what you need to mention. I will talk about it in slightly more detail. Now, this is the creating of manure, which so that, you know, if I show it visually, you will be able to understand it better. So what this farmer is doing is to kind of put all the vegetable waste, etc., in this kind of a big container, right? And that will get converted into manure. Then he can use this manure and use it for all the plants in his field so that the plants develop well. So this process is known as composting. Okay, compost. It is known as compost. The process is known as composting. It is a natural process where organic waste like fruit and vegetable peels, leaves, and leftover food decompose with the help of microorganisms, turning into nutrient-rich manure, which is called compost. So compost, if you are asked what is compost, compost is a nutrient-rich manure which is prepared by this process. Okay, this is what you need to know. Please take a screenshot. It needs microorganisms like bacteria, fungus, or earthworms. When earthworms work on it, it is known as vermicomposting. When earthworms are used, it is called vermicomposting. Otherwise, it is just known as composting. Vermicomposting is a type of composting besides oxygen and moisture. So what are the things that you need? You need moisture, you need oxygen, you need either bacteria, fungus, or earthworms in order to prepare the nutrient-rich manure, which is known as compost. The process is known as composting. I hope this is clear to you. Okay. Now, the other thing which I just now mentioned, I thought I'll show it to you visually so that it's easy for you to understand. Move up, man. This is a biogas plant, okay, which you may have seen somewhere in your city. I'm not too sure, but these are called biogas plants. What exactly is biogas? And microbes are a source of biogas. Microorganisms like bacteria and fungus help break down the animal waste and kitchen waste like cow dung, like vegetable peels, etc., in airtight tanks like these. Okay, in where there is complete kind of, sealed. Okay, these are called the biogas plants. When there is no air, that means no oxygen is provided, these microorganisms start eating and decomposing the waste which has been put inside these tanks. As they do this, they release a gas, and this gas is called the biogas. Okay, mainly it is carbon dioxide and methane gas. So please remember these two gases, methane and CO2, which is carbon dioxide, which can be used as a fuel. It can be used as a fuel in order to run, do cooking, heating, run kind of vehicles, even generate electricity. This is used mainly in the rural areas of our country. So biogas is something which is done like this. This is what gives you a visual idea, and this is the entire process of preparing biogas, which is what mainly methane and carbon dioxide. Then the other thing which I wanted to tell you about the effect of yeast. Okay, now what I told you, yeast is a form of fungus, and lactobacillus is the bacteria which helps in the formation of curd from milk, right? It is because of lactobacillus that we are able to make curd from milk at home. You don't have to buy curd every time from the market. In many foreign countries, you have to buy curd from the market for the simple reason that the temperatures, especially during the winter months, is very, very low, and therefore the curd cannot be made at home, because as I said, you need a certain warm temperature in order to be able to make curd from warm milk, right? So they buy curd especially during the winter months. But in India, which is a tropical country, we are able to do that throughout the year, except in winter months where it may take a little longer, right? So yeast, this is how the yeast works on it. This is a cartoonish representation. This is what the lactobacillus does, that is the milk converting into curd. Okay, also it is used even in idli and dosa, where these kind of microorganisms play an important role. Then, okay, let me go back to the text. Let's understand about this scientist called Dr. Anand Mohan Chakrabarty. Now, he's a scientist who studied bacteria, and he developed a patent. What is a patent? Patent is a copyright given to a person so that no one else can copy, use, or sell his invention without permission. Suddenly you or I cannot say that we are the ones who kind of did a lot of work on bacteria, because that patent is already held by Dr. Chakrabarty, right? So that's how. So he kind of showed through his work that microorganisms could be used to solve environmental problems like pollution. He's remembered for his contributions to science and for protecting the environment using microbes. So he did a lot of work on microbes, because you would wonder, how do they help in the fight in helping the environment? Because he developed a special bacteria which could break down oil spills, helping to clean the environment. What happens? Because when big ships go in the oceans, in the seas, sometimes there is a leak of oil, and all the oil spills in the water, right? You may wonder, samundar mein to hai, how does it matter to us? Of course it matters, because all the aquatic marine life, like different kinds of fish, dolphins, sharks, whales, etc., turtles, they get impacted. Many of them would get killed also, right? So oil spills is something very, very dangerous as far as the marine life, the quality of the water in the sea is concerned. So he developed a bacteria which could actually break down the oil spills, and therefore it was seen as being helpful to the environment. So that is what Dr. Anand Mohan Chakrabarty did. So this is again something which you need to know, because this can again be asked as a question in the examination. Let's now go to, we've already studied that about the microorganisms, what kind of help do they provide in the kitchen, right? I just now told you all this, so we'll go through it quickly. Okay, this is an experiment about how you do the dough, which means essentially the atta, right? In one you mix a amount of yeast, in the other one don't mix any yeast, and then you kind of mix the dough, put it inside a bowl. Okay, so yeast is a form of microorganisms. It belongs to the fungus family. It grows, and when you kind of mix it, the one which has the yeast is the one which will be able to perform better, right? As opposed to the one which does not have the yeast. Similarly, this special property of yeast is used in the process of making breads, cakes, and more. In addition to yeast, some bacteria such as lactobacillus, which I just now told you for the preparation of curd, help in the fermentation of batter for making idli and dosha, and dough in the case of making bhatura to go with chole to eat chole bhature, right? So in all this, you need things like the lactobacillus for making idli and dosha, as well as chola, also bhature. Okay, so these are some of the advantages. As I told you, I've told you three: lactobacillus, bacteria; yeast, which is a fungus; and also some bacteria developed by Dr. Chakrabarty, which help in the preventing or fighting the oil spills and thereby helping the saving the environment. Okay, this is another one which is about the preparation of curd. I told you that if you keep it in the refrigerator, that will not kind of get converted into curd. You need to keep it outside in at room temperature. You will observe that in bowl A, the milk has turned into curd after a few hours, which has been kept outside. Okay, it has also become a little sour if you keep it for a very long period of time. थोड़ा सा खट्टा हो जाता है. Whereas in bowl B, which has the milk has not been converted into curd, but it might be a little sour. Do you know why this happens? The curd contains different types of bacteria. One of them is lactobacillus. This bacterium feeds on the sugar in the milk, which is lactose. Okay, the sugar which is there in the milk is called lactose. Multiplies and ferments the milk to form curd. Instead of producing alcohol like yeast, these bacteria produce lactic acid, which makes the curd sour. These bacteria grow well in warm conditions. That's why curd is formed in bowl A, but not in bowl B. Now, the other things is this kind of root nodules of a plant which contain rhizobium, which is again something which you studied in social science in class 7. Okay, your part 2 book, The Story of Indian Farming, we studied that in there. Okay, so you have some bacteria called rhizobium form these swollen regions called nodules. So you have this kind of, you are seeing this kind of enlarged portion. These are kind of containing bacteria called rhizobium. What these do, and this is something very significant because they are very useful as far as agriculture is concerned, and that's what I told you. Let me do a quick recap, because if you grow the same crop like paddy or maize or wheat, right, over a period of time, all these plants need a lot of nitrogen from the soil. But because they keep using the nitrogen does not get replenished, which means there is no fresh supply of nitrogen to the soil. So you need to have plants which will once again produce nitrogen. So when you grow different kinds of plants like peas, for example, mutton, so there they have the root nodules which will have this bacteria called rhizobium, which will trap the nitrogen and leave it in the soil. And then when you grow wheat or rice, paddy or maize, they can use that nitrogen inside the soil. So that's what it says. These bacteria trap nitrogen. This is what is important from the air and make it useful. What bacteria? Rhizobium bacteria. Make it useful for the plants. This helps plants grow better without chemical fertilizers. That is why farmers grow legumes. Legumes is all this kind of nuts in rotation with other crops. What we studied about crop rotation. You have any doubt? Go to the first chapter of Exploring Society, part 2. Okay, where is the textbook? I'm trying to locate the textbook. This is part 1, part 2. I think I've kept it somewhere else. Can't find it out here. Be somewhere. Okay, so if you don't have, this one, the first chapter of this one, The Story of Indian Farming, has a section on crop rotation. If you have any doubts, go and look at my video. You will be able to find that. This is what is talking about the crop rotation policy, wherein you use these kind of legumes in order to increase the amount of nitrogen in the soil and keep it healthy for the next crop. So if you grow paddy or wheat, then you will grow some legumes or some peas so that the nitrogen supply in the soil gets better. Okay. Then amazing microalgae. Now this is something which is happening in the aquatic life inside the sea. So microalgae are microscopic plant-like organisms that live in water, soil, air, and even on trees. They can make their own food using sunlight. While using this, they also release oxygen and produce more than half of the Earth's oxygen supply. This is something very amazing because inside the sea, you have many such microorganisms, microalgae in particular, which actually produce a large amount of oxygen for the Earth, which is why I said the marine life is so very important. When you have things like the oil spills, even this microalgae get killed, and that will affect the oxygen supply in the world. Isn't this fascinating, right? So they are rich in nutrients and serve as a food source for many aquatic animals. So many aquatic animals, it could be fish, it could be different kinds of whales and sharks, etc. They also feed on this microalgae. Now, this is something which you may have heard about, something called the spirulina. Okay, spirulina or chlorella or diatoms are also used by humans as health supplements, that if you want to improve your health, and this one in particular is very popular, spirulina, which many human beings take as health supplements and medicines. Microalgae also help in cleaning water and used to make biofuel. However, pollution, climate change and habitat destruction are threatening microalgae algal diversity and abundance. It's important to conserve these tiny organisms. Now, for what? One, the oxygen balance, and also because they are food for all the different marine life. Okay, spirulina, which is a microalgae, is known as a superfood. Okay, so you can get a question as to what identify which is the superfood among these four, right, in a MCQ. Because of health benefits, spirulina is also a good source of vitamin B12, which many people are deficient in, including me. Vitamin B12, you end up taking tablets, right, which is essential for our body. It has a lot of protein, more than 60% of its body weight, and only a small amount of fat and sugar. So spirulina in that sense is a fantastic health supplement and a superfood, because 60% of its body weight is actually consisting of protein, right? So what people do is to grow spirulina now, because then you can sell it and actually make money, because people are buying it as a superfood. So this is the process of actually growing spirulina. If any one of you is interested, you can actually try this out at your home if you have the space. Now, finally, we come to why is the cell considered to be a basic unit of life? The body of all living organisms are made of tiny building blocks called cells, what we started with, right? Which have more cells. They are known as multicellular. If you have only one cell, you will be known as unicellular, which is single-celled organisms, right? Other microbes like algae and fungi are made up of one or more cells. You can be both unicellular as well as multicellular. For example, yeast is a unicellular fungus, while mold is a multicellular fungus. Mold is again something which also gets formed on walls, etc., right? It gets formed on walls, it gets forms on bread, etc. That will be known as a mold. Now that's a multicellular, while yeast, which is used for baking, it is a unicellular fungus. So these kind of distinctions you need to be able to remember and recall in the examination. Now, like animal and plant cell, the cells of microorganisms are also surrounded by a cell membrane, which we studied in the first part of this chapter. Cells of fungus additionally have a cell wall. So fungus has a cell wall in addition to a cell membrane. Okay, otherwise most microorganisms definitely have a cell membrane, but they do not have chloroplast, so they cannot make their own food through photosynthesis. Okay, so it's not something like leaves, you cannot manufacture your own food. Bacteria do not have a well-defined nucleus and a nuclear membrane. Instead, they have what is called a nucleoid. What we just saw in the previous page, they just have a nucleoid. And this is what distinguishes them from cells of yeast, protozoa, algae, fungus, plants, and animals, that bacteria has a nucleoid. They do not have a nucleus. They do not have a nuclear membrane. This is the major distinguishing factor between a bacteria and plants, animals, humans, fungus, algae, etc. Okay, so these are some of the thing. The other important thing which I need to highlight is that an electron microscope magnifies the cell about 10,000 times, where we can see more structures present in a cell, right? A 1 followed by 6 zeros. By now you must have understood that all living beings, including microorganisms, are made up of one or more cells. Their cells differ in size, shape, and structure. Plant and animal cells also have some differences. Understanding these differences help us how these organisms function properly and differently. With this, we come to the end. I will do a proper test paper on this particular chapter separately in a video, which will be like a 40 or a 50 mark question, which will be competency based questions, which will test your understanding. So Please go through these 2 videos properly so that you can be well prepared to answer the questions along with me. That will not be an easy lollipop rasgulla paper. It will be a tricky paper which will test your understanding ki kitna samajh mein aaya, and I'll make sure that the reasoning questions are certainly of a high quality. Okay, so I look forward to seeing you in that video. We will now next move to the chapter on health, which is chapter number 3 in your textbook Curiosity. So what you need to do now is to share this video with your classmates and friends, and also subscribe to the channel, because very few of you have subscribed and the community doesn't grow, which does not really encourage me to do a lot more videos for all you students. Tata, bye bye. Thank you very much.